So for the next problem, we are asked to plot the infiltration rate F versus the infiltration volume, capital letter F, using the GREEN-AMPT equation. So the soil properties are as follows. The maximum hydraulic conductivity is equal to 1.97 inches per hour. The saturated moisture content is equal to 0.518. The initial moisture content, 0.318. The suction, so negative 9.37 inches. And the rainfall intensity, which is equal to 7.88 inches per hour. So notice that our rainfall intensity I is greater than our maximum hydraulic conductivity. So we can write for the solution, I is greater than K sub S. So if this is the case, our infiltration rate is equal to the rainfall intensity until the volume Fs is reached. So after that, our infiltration rate F is given by Ks times 1 minus M sub D psi all over F. So the maximum hydraulic conductivity is already given, as well as the suction psi. So what is the MD, or the initial moisture deficit? So MD is simply equal to the saturated moisture content minus the initial moisture content, because the initial moisture content is the actual moisture content of the soil, and theta S, which is the saturated moisture content, so that is the moisture content of the soil when all the voids of the soil is occupied by water. So this is equal to 0.518 minus 0.318. So this is equal to 0.2. So meaning our moisture deficit is equal to 0.2. Ibig sabihin, yan pa yung moisture content na dapat i-increase para ma-reach yung saturated moisture content ng ating soil. So, substituting, F is equal to 1.97 inches per hour times 1 minus 0.2 times negative 9.37 inches per hour all over F, which is the infiltration volume. So we are going to use Microsoft Excel in order to plot the infiltration rate versus the infiltration volume. So again, Again, our again, f is equal to I until fs. So, before we can plot, we have to find the value of fs. So, okay. So, fs so fs is given by moisture deficit times psi all over 1 minus the precipitation rate over maximum hydraulic conductivity. So, this is equal to 0.2 times negative 9.37 inches per hour all over 1 minus 7.88 inches per hour all over 1.97 inches per hour. So, this is equal to 0.625 inches. So, when f is equal to 0 until f is equal to the fs, our infiltration rate is equal to the rainfall intensity. But after this volume is reached, our infiltration rate is given by F is equal to 1.97 inches per hour times 1 minus 0.2 times negative 9.37 inches per hour or R over F. So, let us now use Microsoft Excel to plot the infiltration rate versus the infiltration volume. So, again, from 0 to 0.625, our infiltration rate is equal to the rainfall intensity. So, after that, our infiltration rate is given by 1.97 times 1 minus 0.2 times negative 9.37. All over F. Okay, let's check. So we can drag and then we can plot this using so this is now the plot of the infiltration rate versus the infiltration volume. So again, since our rainfall intensity is greater than the maximum hydraulic conductivity, the infiltration rate is equal to the rainfall intensity until a volume Fs, which is equal to 0.625, is reached. And after that point, the infiltration rate is given by the GREEN-AMPT equation. So, and this is the plot.